In this question, we're going to solve the bond's yield curve. So we have a table with the current yield curve, and the question says, use these numbers to solve the next few questions. The yield curve for the default-free zero-coupon bond is currently as in the table above. First question, what's the implied one-year forward rate? So that's A and B. Now first, let's solve for A. Let's remind ourselves, how do you calculate a forward rate? The forward rate equals to the difference between the long rate and short rate compounded appropriately, and then minus 1. So A equals long rate 1 plus 11%, compounded raised to the power of 2 because it's 2 years, divided by 1 plus short rate 10%, compounded raised to the power of 1 minus 1. I enter it into the calculator and I get 12%. Now, what about B? Same. The forward rate between year 2 and 3 is the difference between the long rate and short rate compounded appropriately. So that's 1 plus long rate, 12%, raised to the power of 3, compounding 3 years, divided by 1 plus 11%, the short rate, compounded appropriately, so it's 2 years left into maturity, so raised by 2, minus 1. And I get 14%. Okay, so those are the solutions to the forward rates. Just to remind ourselves that the forward rate on the expectation hypothesis equals to the future rate of return at that point in time. Okay, so the second question says, assume that the pure expectations hypothesis in the term structure is correct. Now, if market expectations are accurate, what will the yield curve be next year? A, there will be a shift upwards in next year's yield curve. B, there will be a shift downwards in next year's yield curve. And C, there will be no change in next year's yield curve. Now, let's come back to our yield curve table. Right now, the 1 and 2 year yields are 10 and 11%. Now, we know that over the next year, the expected short rate in year 2 is the forward rate A is 12% instead of 10%. So you see the yields are increasing, and we need to choose A. There will be a shift upward in the next year's yield curve. Question 3. What's going to be the yield to maturity on 2 year zeros next year? So we're standing at year 2, and we're looking at the investment return if we invest in year 2 and in year 3. Invested in the long-term bonds, which is the 2-year bonds. Now, we know the expected return we're going to invest 1 year from year 2 to year 3, which is A, and from year 3 to the end of year 3, which is B. So based on law of one price or no arbitrage, we would know that because there's no risk, the investment return, the yield to maturity of this 2 year zero should be exactly identical as if we invest in year 2 in a 1 year bond, then we roll it over at the end of year 2 through year 3. So the yield to maturity of this 2 year zero should be the compounded return of the A and B annualized. In other words, the yield to maturity of this 2 year zero should be equal to, you have started with $1, you invest in A for a year, then you roll it over, invest in B for another year, That's your total rate of return, but yield to maturity is annualized. So we take this, then we annualize it, raise it to the power of 1 over 2, because it's over 2 years, then we do -1. Now let's plug in numbers. So we have 1 plus 12%, which is the solution of A, plus 1 times 14%. 1 plus 14%, 14% is B, raised to the power of 1 over 2 -1. And we can enter this into the calculator, and I get 13%. So the yield to maturity of a 2-year zero from year 2 to 3 is expected to be 13%. Question 4. If you purchase a 2-year zero bond now, what's going to be the expected total rate of return over the next year? So you buy this 2-year bond today, but instead of holding it until end of year 2 to earn the yield to maturity of 11%, you decided you're going to sell it at end of year 1. So based on no arbitrage, your investment return should be exactly the same as if you have just made a short-term investment that you bought a 1-year coupon bond, 1-year zero coupon bond, and sold it after a year or it matures. So it's going to be 10%. The short-term return of a long bond should equal to the yield to maturity of the short-term bond. The solution would be 10%. Next question. If you purchase a 3-year zero coupon bond now, what's going to be the expected total rate of return over the next year? Now, if you buy a 3-year bond, but instead of holding it until year 3, you're going to sell it at the end of year 1, which makes it effectively a short-term investment. So based on no arbitrage, your investment return should be exactly the same as your investment in a short-term bond, which is again 10%. That's a yield to maturity of the 1-year bond.